Moin and welcome back. In this short video I am showing you how to start with plotting of scientific data in Python. We will use the matplotlib package, which is usually not part of Python, as I have shown you in a previous lecture, but is part of the so-called SciPy stack, and you should install it if you didn't do that so far yet in order to try the examples here. Just a very brief comment before we start about the matplotlib interfaces. There are various ways how you can talk to matplotlib in Python. I will use the one which is called of matplotlib simplified interface, but using so-called instance variables. I will show you in a second what it means. You should know that there is also a very similar approach, but using global variables, which is even easier to type, but it's not that practical if you are writing programs. So I would recommend it to use the one which I'm showing you, but transferring between the two is very, very simple. And there is also a third interface, the fully object-oriented interface, which you would use if you are basically embedding some plots which are created by matplotlib into your graphical application. I won't talk about that at all in this video. Another remark before we start is that in order to render the images, it could depend how you do that depending on what you are using. If you are using IPython and Jupyter Notebook and you want to render the images within the notebook, then you might need basically to add this Jupyter Notebook magic into your, or IPython magic into your notebook as a at the beginning. In Jupyter Lab, which I will use, is not necessary anymore because this is already the default behavior. If you use those tools, then basically the plots which you are generating, they will be pop up into the notebooks themselves. The other possibility is basically showing the plots in a separate window, and this you would use if you are using, for example, Python from a script or from an IPython console. Then whenever you generate a plot, maybe a fencer would pop up, a window would pop up, and you would see the generated plot in this window. And finally, this will also use, and this is a very, very useful options, you can basically create graphical files or store the content of the generated figure in a graphical file in various different formats, and that's of course very, very useful also for everyday's application. So I think the easiest thing to start is that I'm just showing you a self-contained example. So basically here, this is an example, it's just a few lines which plots the sine and the cosine functions in Python. And let's take the same example in the Jupyter Notebook, and I will just execute it, and then we will discuss. And basically you see that I have executed that, and I got here within the Jupyter Notebook an image with the sine and cosine functions marked differently, then the axes are labeled, the ticks are nice, and so on and so on. So basically almost everything looks very, very good already right at the beginning, just with a few lines of code. Now let's have a look, detailed look what we have done in this code. Actually, so basically I was just importing first the NumPy library because we will use arrays in order to plot data, and I was using the matplotlib module, and for the matplotlib module I was using the pyplot submodule, which is basically giving you this pyplot, this simplified pyplot interface. And in order not to have to type too much, I was just abbreviating it as a PRT. Okay, then we were just generating the data. So x, these are the points on the x-axis, and I was using the linspace method of NumPy, which you might know, which is just generating equidistance grids of points, and then basically from those points I was calculating the cosine and the sine function, which I stored into the y1 and y2 variables. And now the plotting start, I was calling the subplots command of the PRT module of the matplotlib pyplot module. And this gives me basically two objects, two handles, which I can use to manipulate the figure. First of all, the axis object as a second object, which will be responsible for the individual plots, the individual curves which we are plotting, and the fig object, which is basically responsible for the entire figure if we want to manipulate the entire figure. We will have a more detailed look at it in a minute. But let's have a look at the x. What did I do with the x object, with the axis object? I was just calling its plot method in order to plot those x values, those y values. So I'm specifying the data, and then I'm specifying some additional options which are basically telling me how the curve should look like, so which color it should have, with which line style and which label. And then I did the same in order to plot the second curve basically into the same plot, into the same coordinate system, again providing the data and again providing the various options in order to customize how the curves look like. Then I was saying that okay, we should make a legend box, so I would like to see the legend box where the legends of the curves are shown, the name of the curves. I was just specifying through the label option, and then I was just calling the plot.show command in order to make sure that the image is created. Okay. And if you do, basically this is this last point I would like to mention, then this plot.show command is not necessary if you are working, for example, in a Jupyter notebook like I'm doing here. I could just leave it away without any problems and I would still see the image. So Jupyter would make sure that the image is rendered again. However, I would always get a text representation of the last object which was created, which is here the legend box, and you can suppress it if you use a semicolon and then basically exit it with semicolon, then the last output is suppressed. Alternatively, of course, you can do the original way of doing things and you can just use the plot.show, and then again you won't get this text representation of the last object anymore. Okay, good. Otherwise, depending what you are using, it might be important, especially if you are using a GUI backend, an interactive backend, to use the fig.show command instead of the prt.show command in order to show you the image. So this was the curve or the plot which we have generated, and actually, as you can see, it's already fully featured and looks quite nice. Publication ready, more or less, but of course you have a lot of ways to manipulate the details in matplotlib. Before going to that, I would like to just tell you a few words about this figure and axis object. As I already mentioned, the figure object is there in order to set the global properties of the figure itself, for example, the size or the resolution, or very important, and this you will use probably a lot of time, in order to save the entire figure into a file. And as already discussed, based on the extension, matplotlib would already know what file format you are meaning, and for example here it would really create a PDF file, plot.pdf, in the PDF format. And then we have the axis object, and one axis object represents always one plot in the figure. So basically in this figure which I'm creating, which we created, there was only one plot with multiple curves, but only one plot. So basically we had only one axis object, and the axis object has a lot of different methods where you can basically manipulate where the various things are plotted. For example, I can say that the x-axis position should be top. That would mean that the x-axis would be basically on top of the spine and not crossing it, right? Or I can say that here the y-axis position should be on the right hand side, so basically there would be on the right hand side of the spine, right? I can tell it that basically the x spine itself, so basically the x-axis, should be at the position 0, 0, 0, so the data position 0, 0, and not at the bottom of the figure, right? And for example, I can say that the other one, the other x spine, which would be on the bottom, that should have a color none, which means you see that here basically the x-axis which I had before, it's completely vanished, and so on and so on. And the same for the left spine, which would have been here. I was setting the color to none and it vanished. So basically you have full control over that, what is plotted and how, and you just have to look at the right method how to manipulate it. It's also possible with the subplots, which we called in order to generate the figure and the axis objects, to have multiple plots, to generate multiple plots within a figure. So for example, here I'm just requesting a plot with 2 rows and 1 column. You can have an arbitrary matrix of plots if you wish, but basically that means that the figure will contain 2 plots, not just one, arranged in 2 rows and 1 column, and accordingly I would just get back here 2 axis object instead of 1. The first one would be responsible for the first plot, the upper plot, and the second one would be responsible for the lower plot. And then I can use the same commands as before to manipulate the individual plots, like the plot command, the legend command, and so on. I can apply the same to the second plot, right? So the axis 2, plot and legend, and then when I show it, then you see that I will get a figure with an upper and a lower plot in it. And again, I could, as before, go over this axis and just specify whatever property I want. And because I have two axis objects for the two plots, I could do it independent to the two plots basically in the figure. I could do it independently for each of the plots. The last thing I want to show you explicitly here, or just draw your attention to, is that it's also possible to use when you use matplotlib to render text sequences. For example, if you want to label your axis and you want to use something like pi over half, 3 pi over half, or any kind of LaTeX rendered symbols, then you can use it. And the way of doing that is that you are passing when matplotlib expects a string. If the string is meant to be rendered by LaTeX, then you are using just a $sign, and between the $sign the LaTeX sequence. For example, here I was specifying pi over 2, so the frac command in LaTeX would basically here render pi up and 2 down. The only thing you must be careful that LaTeX commands are needing, or they need as a backslash as a first character in order to tell LaTeX that it's a command, and that can be a problematic thing, because you know that also Python treats backslash as a special character. So as, for example, \n we had just in the previous lecture is a new line character. In order to make sure that this backslash and the character after that is not interpreted by Python as a special character, you can just here enter the R or add an R prefix to the string. Then you are creating a so-called row string, and the row string in row strings Python basically omits to parse or parse it for special characters. But then when Python sees a backslash character, it will treat as a literal backslash character, and it will pass it accordingly to matplotlib. So whenever you are passing text sequences to matplotlib, or later if you are using regular expressions, make sure that you are using row strings, because it makes the backslash handling very easy. You can just write literal backslash characters and you don't have to escape them by some complicated means. So the last thing is that I want to mention that there are tons of useful methods of the X objects in order to create very different plots, and basically I definitely won't go through them because there are very many. Matplotlib is super powerful, and you should try to have a look at these possibilities. And the best thing of to do that, there are a lot of very good excellent tutorials in the net, and I would suggest basically you to start when you stop this video. Just switch to the matplotlib quick start guide and follow with the matplotlib quick start guide. That guide is so good that it wouldn't make any sense that I'm reproducing here or mimicking here. So I'm just recommending that you turn to the matplotlib quick start guide, and if you go through that, you will get a very good idea how matplotlib works, and you will have a showcases. So try all the examples in your Jupyter lab or whatever framework you are using. Try all the examples to get a rough idea what matplotlib is capable of, and you get have a rough idea who you have to start to create various different figures. And then afterwards, basically, if you have some more complicated problem, you would roughly know where to start and where to look up the details. The last remark before we finish here is that the Matplotlib Quick Start Guide uses the same notation, this instance variable notation, which I have used in this course. Another very nice tutorial is the Matplotlib plotting in the SciPro lecture notes, which I also recommend for advanced users. In this, I have also linked it here from the slides. In this video, in this tutorial, they are using the global interface, the global variables, but you can either you can use that one as in the tutorial, or you can easily convert it. So with that, basically I'm finished, and then I'm wishing you a lot of fun with the Matplotlib Quick Start Guide.